Hello friends, welcome to the DSA practice group. Welcome to the video number 17, which is corresponding to question number 17 of the group, or the question number 15, third question of the stack. Okay, you must be seeing a link below, or below there will be a description of our data structures and algorithms practice group. Okay, before I jump on to explaining you the solution for the particular problem, let me just introduce you about the group also. So I'm running a group on data structures and algorithms mastery practice, where questions are posted and students have time to try it by themselves. Okay, and if they get stuck somewhere, they can always message me and I try to resolve their doubts and push them forward. And even if they are not able to, I always post the solutions, most often in the form of a video like I'm posting over here, so that people can watch those videos and do that solution. Okay, generally an aim should be that you should be able to complete it in within 24 hours. Okay, let me just explain to you something about myself also. My name is Akshaya. I am from IT Delhi BTech Computer Science graduate who has worked in companies like Amazon and Paytm, and also my students have cracked companies like Microsoft and Paytm and working at very handsome packages. Right? So I have been teaching a lot of students for a long period of time, and in addition to just helping you solve a particular problem, I am going to introduce a lot of tips and tricks in this video which are going to help crack those interviews, right? So do watch the video entirely, because in addition to the solution, I'm going to give you a lot of tips and tricks. And in case if you are a serious person who wants to seriously crack these companies, and not in a long period, maybe in just 1 month or 3 months, you can join the group by clicking on the link given in the description or in the video, and I will be there to help. Okay, but it's only for serious people who really want to put in the effort and maybe aim to get it into it in 1 month, 3 month, and maybe even longer period of time. And it doesn't really matter what is your current status. If you're ready to put in the efforts, I'm sure that you can do it in 3 months. Okay, 3 months is a good enough time. Okay, now let's jump on to the problem. Remove all adjacent duplicates in a string. As I always say, always spend good amount of time in trying to understand the problem and take examples, right? So let's try and see. Given a string S of lowercase letters, a duplicate removal consists of choosing two adjacent and equal letters and removing them, right? So you are given a string S. Okay, a string S has been given, and what you have to do is you have to find two adjacent characters which are exactly the same and remove them. Okay, and you have to recursively do it, because it says repeatedly make duplicate removals on S until we no longer can, right? So keep removing two pairs of characters which are adjacent are same, and leave the string when there's nothing which can be done. Okay, return the final string after all such duplicate removals have been made. It is guaranteed that the answer is unique. Okay, one very important thing to note is it is guaranteed that the answer is unique, though it doesn't affect the way the answer will come out, or how you approach the problem, but it gives you certain kind of hint about the problem, that you can apply any kind of algorithm, any kind of priority between choosing two different pair of adjacent character who are same, and you're still going to get the same answer, right? So you can be more free in the approach of choosing whichever character you want to remove. Okay, so to better understand the problem, let's take some examples. So you're given the input string ABBACA, right? So what does it come intuitively? It comes intuitively that these two characters BB are same, right? So what we should do is we should basically remove them. Okay, let me just write this down for you, and then we can understand how we are actually doing this. I will also suggest each one of you to actually do this on a piece of paper, or at least type it on a notepad. Okay, so the string is ABBACA, right? So how does a human does it? Solve the problem by removing these two characters, right? So what will be left is AACA. Very good. As soon as this is done, you see that these two characters are also the same, right? So what should be the next step? You're going to basically remove these A, and that's why you will be left with CA. When you get CA, you see that there are no characters which are same. No two adjacent characters we are same. So you can leave the answer as CA, right? Very simple. Okay, now let's take another example. They must have given another example. Okay, they have not given any example in this case, but they have told you that the length of the string is less than this much, and S consists of only English lowercase characters. Okay, so just for understanding, we should take more and more examples. Okay, let's say if there was an empty string, sorry, if there was a string which had only two characters and both were same, so in this case we are going to leave it as empty, right? And just to keep everything in the same space, let me just represent them in this way. So if you get A, you basically get nothing, right? Let us try take more examples. A, B, C, A, D, C, A, B. Okay, very random example. So, and let me just do another thing. Okay, so as you can see, there are two positions from which you can remove two adjacent characters, right? One is over here, which is double A's, and one is over here, which is double B's, right? So you can actually follow any approach and you can remove any character, double character first, because the question has already told you that you are always going to get the same answer, okay, no matter what algorithm you follow. Okay, so let's just remove this double A and see what happens. When you remove this, you get A double B, C D D, C A B. Very good. Now as soon as you do that, you see that these two B are the same and also these two D are the same, right? So you can remove either of them. So let's just remove these two B's and see what happens. So you get A C D D, C A B. Excellent, right? Now you can remove these two D's, A C C A B, right? And then these two C's can be removed and you will get A A B, right? And then these two A can be removed and you will get B. Very simple, right? So let's just write down the pattern, what we are doing. Find two characters, two adjacent same characters, remove them, and then repeat this process, right? So you have to basically do this. So this can be very easily converted to a for loop, right? That while there are two adjacent characters to be removed, keep removing them, right, again and again, right? So we can just write this as while string has two adjacent same characters, remove the two adjacent characters, right? That's what we have to do. And as soon as we come to a situation where we don't have any character for removal, when we do not have any character for removal, we can stop. Okay, now as always I say this, that always for doing anything, go to the basics, break down a bigger thing into a small thing, right? So we just brought down this intuitive algorithm out of nowhere and we gave words to it, steps to it, right? Now what I'm going to suggest you is, after you have written this, break it further down. Okay, see if you understand the command for each of them. Okay, so while string has two adjacent same characters, how do you find two adjacent same characters are there, right? How did we do in this one? As humans, we can visually see this string of letters, right? And we can find out that directly that double A is the problem over here, right? Double A is the problem over here. But machines or computers don't think like that. They take information bit by bit, right? So they take one information, then they move ahead, see next information, move ahead, like a state machine, right? They are basically a state machine. Okay, so how will a computer read this information? It's going to first read A, then it's going to read B, and so on and so forth. You can even start reading from the back side, or maybe you can just start randomly from some position and then go to the left, go to the right, right? So a machine reads it bit by bit, right? So that's what you have to think also, like how can we convert the logic that we have as humans to how the machines think, right? So let's now think it like this only. Let's assume that whatever is highlighted has not been seen, or let's say uh, we can only see one character at a time. Okay, so the machine reads A. Machine knows this is the first character, so not a big deal, right? Let's and it will say if the present character is A, let me check the next character. Is the next character same as me, the current character? If yes, then I can remove this, right? So when the machine is at A, it will look at the character B and it will say these two are not same. So no problem. Let me move to the next one, right? So the machine now moves to character B. When it is character B, it for sure knows that my previous character cannot be same as me because I had been checking this for a while right now, right? This kind of concept which I am telling you right now is like a loop invariant which you should study in detail. Okay, I will try to make a video on that also maybe sometime, but here it will just make the video too long. So let's jump ahead. So character B right now, the computer checks that should the next character also same as me. So they say yes, the next character is also same, and that's when the computer decides. So basically I have to remove the current character and I have to remove the character coming next, right? So as a result it could have removed that, right? So let's just see what happens if the computer does that. This is the way how I did, and I could have chosen either these A's or I could have chosen these B's, right? But computer being a machine is able to not make a choice, and it will see these two as first, so it's going to remove these. Okay, so let's just do that. A C D A A D C A B. Okay, so the machine did that. Okay, now how does a machine know that it needs to remove same characters in the current string? It cannot know by its own. It will again have to traverse the string starting from the beginning. Okay, it may actually start from one character before that we started, but let's not just complicate. Let's first try to think of a simple logic. Okay, and as I'm explaining to you this logic, it may seem very tedious, it may seem very lengthy and very elaborate, but because most of you are beginners or you don't have that experience of cracking those interviews or cracking the hard data structure algorithm problem right now, practice everything elaborately on a piece of paper. Once you master that completely, what will actually happen is this will become a part of your mind. Okay, you will develop a framework in your mind, and this will happen automatically inside your brain, and you wouldn't have to actually think of it, right? It will happen in your mind, and these small decisions you will be making when you are solving big data structure and algorithm problem, very complicated data structure and algorithm problems. Those problems, those logical problems are actually based out of a lot of small logical decisions which you make. Okay, and each of those logical discussions is like what I am doing right here. But if you don't practice that over here, what will happen is this logical intuitive behavior will go inside your head without your awareness, and you will make a lot of faults, right? And that's why it is very important to practice the basics. That's why practice breaking down the logic very small. If you do that, if you make your basics very strong, your advanced concepts are going to become very easy. But if you screw up your basics, no matter how much time you give for solving the advanced problems, you won't make it. Okay, so first focus on the basics. Okay, so the machine again comes to character number A and tries to check whether next character is same. It sees that it is not same because that is C, right? So now it moves to character C and it sees whether C is same as the next character. No, it is not, right? So it will again move to the next character. D again not same as the next character, right? Because next character is A. But when it comes to A, it sees even the next character is A, right? This character is also A. So it knows I just need to remove these two characters, right? So let's just remove these two characters and we get DCAB. This is what the machine gets. Okay. If you look at this one which we did manually and this which we are doing by the computer are actually become the same. We had actually chosen to first remove this double A, but computer chose to remove this double B, right? So we are still in line with the question that the answer is always going to remain the same no matter what algorithm or approach you follow. Okay, so computer has removed again, but the computer doesn't know whether it needs to remove more or not, right? Because as a computer, you have a blank screen. You don't know what just happened. You're going to read one character, the next character, and so on, right? So let's become that computer. So the computer first reads character A and then sees the next character is C. So no need to remove anything. Then it jumps to the next character C and sees the next character is D, which is again different. So again, you don't have to do anything. Then you come to character number D. When you come to character number D, the character which follows D is also the same. So computer knows I am standing at D and the next one is also D. So this is a place where I need to remove these two characters, right? So it will just simply remove these two and we will get A, C, C, A, B. Excellent. Okay. So again, the computer doesn't know if he has to remove anything or not. So it is going to traverse the string again, right? So it will first see the character as A and then it sees the next character as C. So nothing needs to be done. Just jump to the next character. Then it jumps to character C and sees that the next character is also a C. And that is the exact condition needed, right? So these two characters will be removed. So the computer is going to do this. AAP, right? Again, the computer doesn't know if there is a character to remove or not. So again, it will start from the first character, sees this is A, the next one is A, so these two are to be removed, so it will going to remove these two and we will get B. But the computer still doesn't know that there is exactly one character B. We in our intuitive mind are able to see multiple things together, but the computer doesn't. Okay, so we as humans, when we reach B, we are not going to do anything. Okay, but the computer is going to do even now. So computer will read the first character, it will see it's P, right? And it will know it cannot see the next character, right? So it will know, okay, so there's no character to be matched. But again, the computer might again do the same thing. The computer might still think there's something to be removed because we didn't tell what is a stopping condition, right? So can you think of what is a stopping condition for a computer to do this? The stopping condition is very simple. Stopping condition is let the computer traverse the string and try to remove a duplicate characters. If it is able to remove some duplicate characters, try again in the next one. But if in the current traversal, it traversed the entire string and didn't get any character to be removed, don't be stupid enough to try that again, right? So once computer traversed this and it identified that there was no two characters which were removed, this basically means the entire string has been traversed, and no matter how many times you're going to travel it again and again, you will never come across two characters which are same, right? So we can actually stop it over here and we will get the answer. Okay, so it will know that nothing can be changed and it will stop over here instead of going again and again. Okay, if this is confusing, try to pause the video and come back again, but I suppose you're going to find it very interesting. Okay, I just now told you that this, as a human, when we come across B, we don't go ahead, right? But actually that's a bit of a lie. You know why? That's the case because when you see this letter B, you actually thought in your mind this character is only single length and it cannot have two characters which are the same, right? And that's how you know to stop. Okay, but as soon as I gave you this example, this just proved to you that a lot of things, lot of proofs always happen in our brain intuitively. Okay, basically meaning happening inside our brain without our awareness. And if you are not aware of that, there can be a lot of mistakes in that, right? So even in over here, we found intuitively that we should stop over here, but always try to bring your logical mind and try to find the reason. Why is that so? Okay, and that's why it is very important that whenever you solve a problem, try to work out the reason in it, that why it is working, and try to break a big problem into small problems and work each step logically. Okay, so good. Till now we have identified how does a computer identify file string has two adjacent same characters, right? The condition for this would be that traverse the entire string, see if there was something which was matched, right? Maybe inside this while loop we can mark a flag if two characters, if two adjacent characters were same and getting removed. If they are, we will check inside this while loop, right? We will check this flag. If the flag is true, we are going to repeat the process. If the flag is false, we will stop and we will give the string as answer as it is. Okay. And how do we remove two adjacent characters? Now this is entirely a syntactical thing. This is not a logical thing like we kind of figured out over here, right? We kind of figure out logic over it. This is kind of a syntactical thing which according to the language that you have, you should be able to do. Okay. So knowing the basics of syntax of any particular language is also a part of the basics. I hope you you have someone good language that for which your basics are strong. If not, then you can reach out to me for a course on that, or maybe you can just look up on the internet and get your basics strong. Okay. So now let's convert this into a solution with a working code. Okay. And the solution which I'm giving you right now is a very basic and very simple one. I'm going to improve on it in a short while. Okay. So to save upon the time, I have already kept the answer ready, the actual code ready for this. Okay. And let me just share the code with you. Okay, one very important thing. I'm using a string builder over here. Okay, I have introduced string builder in the previous videos also, but I am going to share about the string builder again because the previous videos were Hindi and maybe some of you didn't know about it. Okay, so Hindi is an Indian language. Okay, so Indian spoken language, not like a programming language. Okay, so let's come back. String builder ans. Okay, so basically for a string in Java there are three ways. One is string, another is string builder, and another is string buffer. Okay, there's a difference between them. The difference between string and the other two is string is not mutable. Okay, what is the meaning of mutable? It basically means if you have created it once, you cannot change its value. Let me give you an example. Let's say int x is equal to 155, right? Then you can say x is equal to x plus 1. So x becomes 156, right? So the value of x changed. The same memory box where 155 was stored, over there 155 will be extracted and in its place 156 will be stored. Okay, so an integer is mutable. But string, what happens is, let's say the string x is equal to abcd is stored and you say string x is equal to abc. Instead of emptying the box of abcd and putting abc over there, a new box will be created. Okay, a new box will be created abc and this x will become equal to that. Now why is this important? This is important because if you are going to change a string, okay, if you are going to change a string with a very small operation, maybe even just removing one character, okay, or maybe doubling the size of the string, the problem is that the time complexity done to do so won't be the same as won't be exactly like order 1. Okay, you will have to copy the entire string again and again, all the characters, and that's how it is going to work. Okay, that's why a better way to perform operation on strings is through with the help of string builder or with the help of a string buffer. Okay, now there's a big difference between string builder and string buffer. Actually not a very big difference. It's actually practically the same with a slight difference that string buffer is useful for operations which required thread synchronization. Okay, basically you can access the same variable through multiple threads at the same time. It's something which will take even more time and I don't even more study more a lot on that, so I won't go that deep on that. I will just introduce you on string builder. String builder is like a string, but you can perform the operations on it without worrying about lot on time complexity. Okay, so let's come to string builder. Ans is equal to new string builder. Okay, we just created a new string. We just converted s to a string builder s. Okay, and because of this, our space complexity increased by order n, where n is the length of the string. Okay, more on space complexity later. So boolean remove last is equal to true. Boolean remove last is equal to true. Now what is this boolean remove last equal to true? Remember I told you check flag, right? So this is basically going to tell the computer that okay, in the previous iteration we could find two characters which are same. So you may check again if there are two characters. If in the previous iteration no characters were removed, this basically means even in the next iteration nothing will be found, right? So that's why remove last equal to true. You can use this for that. Okay, and as soon as you enter the loop, assign remove last equal to false. Why? This is so because once you have entered the loop, in this loop you may remove two characters or you may not remove two characters, right? And that's why if you don't change this remove last equal to true equal to false, it will remain true and you will be caught up in the infinite loop. So because the purpose of the remove last equal to true was to ensure that the loop continues, right, to check whether the two characters were removed in the previous one. Only in this while statement, as soon as the purpose is done, convert that to false. Okay, next thing, if answer dot length is less than equal to 1, break. Okay, basically this means if our answer string has only one character or zero character, there's nothing you can do about it, right? If you can do nothing about it, just return it, right? Why cannot you do anything? Because for characters to be removed, two adjacent same characters to be removed, they should at least be two characters, right? So that's why at one I am removing that. Okay, and why I'm doing that? Because in the next steps I'm going to check iteratively that whether the current character is same as the next character, and if I don't check for less than equal to 1, it may give array index out of bound exception. Okay, and what does the break over here does? Break does a very simple thing, that it just tells whatever while loop I am in right now, the computer is in right now, just break that and get out, right? So this while loop bracket is still here, so because of the break it will come directly out of this, and there it will just return answer. Okay, now let's see what's happening next. So at least one, right? So we know there's at least one character, so what do we have to do? Let's just check our pseudocode. Remove two adjacent characters, right? And how do we remove two adjacent characters? We followed this strategy, and what was it? It was basically traverse the string one character at a time and keep matching the current character with the next. As soon as you get that, remove them. Okay, so int I is equal to 0 up till ans dot length minus 1. So why did I do ans dot length minus 1? I did ans dot length less than ans dot length minus 1 instead of just less than ans dot length, because let's say if this I become equal to ans dot length minus 1, right? If this condition was not, it may become equal to ans dot length minus 1, which basically means the last character. Ans dot length minus 1 refers to the last character, right? Would there be any character after that? No. So if you try to check this character being equal to the next character, it's going to lead to array index out of bounds exception, right? So we just need to move I till the second last character, and that's why I put this condition of minus 1. Okay, so now let's see if answer dot character at I is equal to ans dot character at I plus 1, basically saying the current character and the next character. If these two are equal, what I will do is I will remove these two characters, right? Okay, so when I am removing, why do I say I comma I plus 2? Okay, the reason is very subtle, not very subtle. It's because in Java this first index corresponds to the starting index, and this index corresponds to 1 plus the index from which you have to return, right? So this basically means remove characters from ans starting from I up till I plus 2 minus 1, which is I plus 1, right? Whatever number, let's say if this is 10, so you will remove characters up till 9. If this was 6, you will remove characters up till 5. So basically one less than that, right? So ans.delete will work like this. Go from I to I plus 1, that is the current character and the next character, remove that, and then marked remove last equal to true, which will be useful when you come to this while loop, right? So that's exactly what is happening in this problem, and we will be able to do it. Okay, let me just run the code and show you. Actually just submit it because I have already run it and submitted it. Okay, so it's working. You can see the runtime is quite high. It's not as fast, okay, but the memory usage is better than 100% of the problems. Okay, now comes a very important part. Okay, most of those people I have seen, they just run after solving the problems. They just get the answer somehow. Okay, sometime, and they forget about the logic part of it. Okay, I already told you, identify the logic, see how you actually solve the problem, use the problem for learning the art of problem solving. I have actually created even a course entirely on that. Okay, so learn the art of problem solving, and at the same time optimize your code for time complexity and space complexity. Okay, this is very crucial. Just being able to solve a problem is not enough. You should be good at code optimization, and I'm going to introduce to you a very small part of that, which is just finding the time complexity and space complexity. The concept of code optimization is so wide that it can be even a semester course, or maybe at least 1/3 of a semester it can take. And I myself have gone into a lot of depths of that, understanding the basics of this code optimization part, and created another course on that. So let's try and understand what is the space complexity and time complexity of this code. Okay, so if you see the space complexity, how many extra memory blocks you have created? You have created this string builder, right? What is the space complexity because of this? It will be the same as order length of the string. Okay, you have created a boolean, this is true or false, so this will add another one to your space complexity, right? Then int is created, so another addition, right? And maybe there are other variables also which I missed. So at the max you are storing n variables together, n plus 5 6 variables together, right? Which in terms of asymptotic analysis become order n. That's it. Okay, so space complexity is going to be order n. Now let's talk about time complexity. Okay, so time complexity, we know that this operation is 1, or maybe you can say order n because length of this entire string. Then this is 1. Then we have a while loop, right? While loop, how many times this while loop is going to run? This is going to run as many times as there are double characters in the string, right? If let's say the string has n characters, how many times this will maximum run? It will run n by 2 times, right? It will run n by 2 times, because in each iteration you're going to remove 2. Okay, so because of this you will get n by 2 times the number of operations which are happening inside this, right? So let's try and understand how many operations are happening inside this. This is 1, this is 1 1 1. Now you have a for loop. Let's try and understand how many times the for loop iterations are going to run. Okay, so we are going to start from I equal to 0, and we are going up till this, which is basically length minus 1, which is basically n minus 1. So in the worst case scenario, this loop may run n minus 1. Okay, after being removed 2 characters, it might actually go like n minus 1, n minus 3, n minus 5, right? So this loop, inside the loop of this while loop, operations would be, first time it will be around n, then after that it will be around n minus 2, then n minus 4, and so on and so forth, right? So that will become a series of AP, and that will come to be around n square. okay, and because of that the time complexity is order n square. Okay, so this was a simple approach. Now let's try to go a level up. Okay, let's try to solve the problem in a better way. Let's try and see if we can solve it with a better time complexity or better space complexity. Let me just write down the space complexity which we this so that we know what to improve. The time complexity is order n square and the space complexity is order n. Good. Okay, so remember when we were doing this, I told that the computer has a choice. And what is a choice? That let's say when the computer removes the two characters, instead of moving to the beginning in the next loop, it can actually stay where it is, right? For example, let's say computer had somehow removed these two characters and had come over there. No, that won't actually work. Yeah, so let's just go with this example only. If the computer removes bb, right, and it comes to these, it knows it knows that in the worst case scenario, let me actually do something. Let me add more examples over here so that it becomes easy. Okay, so let's say these two or rs were present in the beginning, right? So once the computer removed these two characters and it formed this, it knows that because of the removal of these two, the only place it will ever impact is in the string starting from the previous character to the next, right? That is starting from a up till this. The characters before this are not going to be affected, right? Because those characters are still the same. Only thing is this a might meet another a in the next position, right? So because of this, the string doesn't have to move behind and it can actually start from here. Okay, so it will start from a and it will see that no change has to be made, so it goes to sees that the next character is d, so again nothing has to be done. Then it reaches d and sees that the next character is a, so again nothing has to be done, right? So da can be removed. Now it reaches a, and when it reaches a, it identifies the next character is also a, so it's going to remove these two, right? And as soon as it removes these two, we will have tors acd and all, right? And from where did we remove these two a? We removed these two a bit from between these d's, right? So the computer knows that all the strings before this double a, only the letter d may be affected. All the characters before the letter d won't, we don't have to check them, so we just have to check over here. So computer will directly come over here and then match these two. Now what is the advantage of this? The advantage over here is that we don't have to traverse this entire string again and again. We are just at this character and either we will go ahead or we will just check one character behind. And because of this, the entire string won't be traveled more than 2n. I'm saying 2n because see, the string is going to travel ahead, right? It's going to travel ahead, so we have at least n, and at the same time when it's traveling ahead, it will actually check the previous character also. So the previous character might be traveled multiple times, right? And only once that will happen in the entire iteration. So because of that, you can have a good upper bound to the operation will be 2n, which is actually order n, right? So again, when you are over here, you will remove these two d, and computer knows that once I remove this two d's, I don't have to start from the beginning of the string, but I can begin from here, right? So it will begin directly from this c and it will continue to do the work. Okay, so how do we actually apply this in code? Okay, so you can apply a very similar strategy which I did over here. that write the entire thing in pseudocode. Think from your own mind what you are actually doing at that step and do that. Okay, so let me give you the hint how you can do that. So what you're going to do is you're going to write, let me just expand this and write over here. You will say that while didn't reach end of string, I am going to travel the entire string, right? I'm going to travel the string starting from 0, then 0 plus 1, 0 plus 2, and so on. While didn't reach end of string, find the next pair of characters. Find the next pair of characters. And how do I do that? If I am at I, check if I minus 1 and I are same. If not, continue with I comma I plus 1, right? Continue with I comma I plus 1 and so on, I plus 1, I plus 2, and you will find out, right? And once you find out, once found, remove them and keep and save where they were removed from. Okay, now this can be done with the help of a string builder. Okay, can be done with the help of a string builder. But now let me introduce you to a better method, a better design principle method of doing this, and this is with the help of a stack. Okay, if you observe carefully, you will get to know how a stack works, what is the purpose of the stack. This question beautifully tells the importance of the stack and where it should be applied. So how does a stack work? Okay, a stack works in a very simple way, that you have anything present, then you put something on the top of it, right? And then you put something on top of it, and then you put something on top of it, and so on. So if you want anything, you have to first pick up the topmost thing. Okay, then you pick up the next, then you pick up the next thing. Okay, then you pick up the next thing, and then you pick up the next thing, and then you pick up the next thing, right? So you're always concerned only what is on the top, right? So if you see over here, once once this double B was removed, and we are just only interested in what is till now what we have traveled. We are only interested in the top value. We are only interested in A. We are not really considered at with torts right now. And if we will be considered, they will be considered only if A gets removed, right? So last in, first out, right? So because A came the last, we will have to remove A first to deal with others, right? So that's why we can use stack to solve certain problems. Okay, so I'm going to give you the algorithm for that. What you will do is, you see the character, you see whether it matches. Okay, you choose any character, and you see your stack. If there is on the top of the stack the same element is present as the current one, then just pop this and move to the next character. Okay, if this character on the stack and the current string character not the same, just push this on to the top, move to the next character. See, this character is same as the top. If not, push this. If these two were same, pop them and move to the next character. Okay, very simple. You can actually try this with the example by actually writing on bits on pieces of paper and try to do it yourself. That's how a state machine also works, right? And that's how a computer also works, and that's why we are going to use a stack. So let me just show you the solution also. I had already prepared it for saving time. Okay, because I can also always make mistakes on the video, and then correcting it might actually take longer. Okay, so I created a stack. In your own programming language, there would be a way to create stack. So just Google it, find it out, have that part learned. In this video we are understanding of the syntactical part of the pseudocode which I explained. So language won't really matter. You just try to understand the logic behind things, because even the companies where you go for the job, they are not going to hire you on the basis of a particular language, right? Because see, languages will keep changing, the same language will keep evolving, your project in the company will change, right? Even if you worked in a different technology but you have that experience of designing the same kind of applications, you're going to bring that experience into the new company even when they're working on a different language, right? So companies actually focus on the problem solving ability, the logical ability, the data structure and algorithm abstract concept, which you'll be able to demonstrate in whatever language you like. But when you join the company, you learn that language and perform. Okay, and obviously if the language is the same as the company, it's going to benefit you a lot. But that said, what really matters is the ability to solve problems, because that will save the company a lot of money. Because let's say after 6 months time, the project changes or your team changes, then and you didn't and the company just hired you on the basis of the programming language, but now the programming language changed, so you will become useless to the company and they will have to hire someone, right? And it doesn't make sense to give you money. That's why the companies focus on someone who can learn things, okay, who they hire for the ability to think, because no matter where they put you, you're going to be productive, right? So that's why they spend so much amount of money in hiring the good problem solvers, and that's why they focus on data structure and algorithm problem, because it's independent of the programming language. Okay, so let's jump into this. So I just created a stack, and now I'm going to follow the same pseudocode which I just explained to you. Okay, so for int I equal to 0, I less than s dot length, I plus plus, so I'm going to traverse the entire string. Okay, if my stack is empty, if there's nothing already present in my stack, right? uh like let me just give you the example also. I think that will be better. Let's say we are working on this string. Okay, let me just write this down also. Tors ab c d a d gap. Okay, so what is going to do is, and let me say this is my stack. My stack is right now empty, there's nothing in this. Okay, so the code checks whether the stack is empty. If it is empty, it's going to push the current character, right? Because the current character doesn't match anything from the previous, right? Because the stack represents what had come previously. So because of this, it will take this t and put it over here. Okay, good. Now it will move to the next character O, and it sees whether the stack is empty. The stack is not empty, it has t, so it is going to check whether this t and O is same, right? So it's check if my stack dot peak is equal to s dot character at I. Peak basically means top, checking what is the last character which was pushed into the stack, which is t right now, right? So these two are not same, so it's basically going to just push this in, right? So O will be pushed, right? So how will the stack look like? The stack would look like something like this, right? O will be on top of it. Good. So now the string reached R. Again, it will see if stack is empty. No, it is not. And it checks whether R is equal to the top of the stack. No, it is not. So R will be pushed on top of the stack. Good. Now it will move to S. Again, the stack is not empty, right? So it is going to check whether the two characters are same. These S is not as same as the top of the stack, so it's going to push S on top of the stack. Good. Now it goes to A, right? And it sees that A is not the same on the top of the stack, so again A will be pushed. Okay, now it goes to B. Again it checks whether the stack is empty. Stack is not empty, so it goes to the else one, and in the else it checks whether these two are equal, which basically means is B same as the top of the stack, which is A, which is not the case, so it will go to the else condition where it's going to push on the stack, right? So B will be pushed on the stack over here. Good. Next thing that we are going to have is, now the string moves to B. Okay, and again it checks whether the stack is empty. It is not, and it's going to go in the else loop, and it's going to check whether this b is same as the top of the stack, and that is. So in that case, what you're going to do is you're going to pop the stack, which basically means remove this b. Okay, good. So now we were at this b. Now the string, the computer moves to next character, which is c. Okay, remember this was the original string. This will remain as it is. Okay, now we'll move to the next character, which is c. Again it checks whether stack is empty. No, it is not. Then it checks whether the stack top is same as the current character. C is not equal to a. So what is going to do? It's going to push. So c will be pushed on the stack. Now it moves to d. It checks whether stack is empty. No, it is not. It checks whether d is same as top of the stack. No, it is not. So d will be pushed on top of the stack. Then again a comes. Stack is not empty. A is not equal to d. So a gets pushed on the stack, and now it moves to the next a. It sees that stack is not empty, but this a is same as the top of the stack, right? And because of that, the stack will be popped. Okay, good. So this a is removed. Now it moves to d. Okay, it sees that stack is not empty, but it sees that d is same as the top of the stack. So instead of pushing onto this, it is going to actually remove the old d also. Very good. This is also popped. Now it moves to character c, right? And when it moves to c, it checks whether stack is empty. It sees stack is not empty, so it moves to else loop. And inside the else loop, we are checking if top is same as character I, and that is really the case. So it's going to perform the operation inside, which is pop. So this c will be popped. Okay, now it moves to character a. When we move to character a, again the same thing will happen, that stack is not empty, but the top is same as current character, so this a will be popped as well. Now string moves to character b. Okay, and it matches whether this b is, it's checked whether stack is empty, and it sees that stack is not empty, right? So it's what is going to do is, okay, I was just a bit confused. Will it come to this? Yeah, it will come to this, because I is less than s length, right? So it is going to come at b. So it sees that stack is not empty. It sees that this s is not equal to this, so it's going to basically push. So it is going to push b also, right? And this for loop will be over because the entire string has been traversed. Okay, good. Now let's see what happens next. So now the string builder will be run, and this stack will be emptied, and it will be converted to a new string, right? So this is how it's going to do. Okay, so until the stack is empty, ans will be inserted, and at which position? It will be always inserted at position 0. Okay, why am I inserting at position 0? Because of the stack, right? See, if we have a stack, if we have a stack like this, right? And if you undo the stack, right, the elements actually get reversed, right? So that's why when we are popping, we will be inserting at that, so that the string which was tossed doesn't get reversed, right? So that's why b will be popped, and it will be put at this position, first position. Then s will be popped, and it will again be pushed at the 0th position. That is, instead of after b, it will come before b, right? Similarly, r will be popped, sorry, s will be r will be popped and will be put over here. Then o would be popped and will be put over here. T will be popped and it will be put over here, right? And this answer is actually the same as this answer. If you remember, TORS was inserted by us to make the problem easier to understand. So the correct answer in this case would be TORS over here. Then even when double A are removed, it will come like this. And this is exactly the same answer as this. Okay, and then we will return ans2.string. Very simple approach. It's a very simple problem on stack. Maybe not simple because you have not done a lot of problems, but I have tried to explain from the point of view of basics by breaking down things into small parts so that you can understand. Okay, I hope you are enjoying the video. Do drop me a like below so that I can know, because the more you encourage me, the more I will be inspired to do more. Okay, and also if you have certain doubts, feel free to comment below to ask them out, and if it's this particular thing which you loved about the video, also share that below so that I can create more of that content. Okay, now let's come to the analysis of the time complexity and space complexity. The time complexity, if you see, as I already told you, we are going to traverse the string only once, right? So it's going to be order n complexity. We might check the previous character, but that's just once, right? So it will be n plus 1 or maybe 2n. So this for loop is running and each of these operations are actually occurring once. So because of this, this entire thing will be done in order n, okay? And this will also be done in order less than n only, because maybe the string became completely empty, or maybe whatever the answer is, this complexity will be order length of the answer, which cannot be escaped. Okay, so time complexity would actually be order n only, where n is the size of the input, because the size of the output is also going to be less than that. Okay, and if we talk about space complexity, the space complexity is also order n, right? So if we compare with what the solution that we had done previously, the previous one took order n square, this one will be done in order n, and the space complexity remain the same. Okay, now comes a very interesting part. Okay, this not everyone understand. This is a very small tip from the point of view of understanding the space complexity and time complexity from code optimization, that you should be able to understand a problem from different perspectives, that which algorithm will be suited when. In this case, we have a clear-cut winner. The second one runs an order n space, right? Order n time complexity and order n space complexity, which both of these are actually less than this, right? So you are always going to use this. But sometimes in some problems, the time complexity might be worse, the space complexity might be better than the previous solution. So in that case, you will have to use your mind and think of different examples where the problem would be there, and in which case you are going to prioritize on the time, and in which case you are going to prioritize on the space. That's why it is very important to try to solve the problem from different perspectives and also analyze which algorithm is better and in which scenario you do it. Okay, so we are coming to the end. I hope you enjoyed the video. Please like, please comment below, also share the video with your friends. Okay, and if you're not part of the group for data structures and algorithm practice, which can help you earn 30 lakhs INR, even if you are India, even if you are a fresher, if you're good at data structure and algorithm, please click the link and send me a message for joining in. Okay, so bye bye, take care, we'll catch you in the next one.